for the next problem. Here he is asking you to draw the SFD and BMD for this particular member. So first you are calculating the reactions. RB equal to 90 kilonewton and RA equal to 30 kilonewton. Now the SFs are to be calculated. The beam again I am redrawing it with the reactions 30 and 90 kilonewton. SF calculations. So first we need to decide where all we need to calculate the SF, shear force. What I told for the shear force, at left and right of point load, start and end of UDL. So here UDL is not there. He didn't told anything in connection with the couple. So only I need to calculate the SF, left and right of A, left and right of D, left and right of B, left and right of E. Afterwards I need to complete the diagram. This is from one of the university question paper. Yes, SF calculations. SF I will start usually from the left end and complete with the right end. SF at A left, that is this location. So I am taking the left part for the calculation. Nothing is there on the left. SF at A left is equal to 0. Now I am coming for the SF at A right. Yes, the new load they are entering is 30 kilonewton and is carrying the left part up. That is why it is 30 kilonewton, but I am writing it systematically as 0 plus 30. 0 in the sense till the left it was 0, and when I am jumping to the right 30 is making its entry. Then I am going for the SF at D left. Yes, no new entry from the A right, therefore it is 30 plus 0 equal to 30 kilonewton. Then I am coming to D right. SF at D right is equal to, already 30 is there, new entry is 60. With respect to my line, that 60 is on the left part. Left part is going down. Left up is positive, therefore left down is negative. Therefore it is 30 minus 60 and will give you minus 30. From there I am going to the B right, B left. No new load between D right and B left. Therefore it is minus 30 plus 0 is again minus 30. From B left I am going to the B right. Again I am considering the left side only. Till B left it is minus 30 and new entry is 90 kilonewton and is acting on the left part, is carrying the left up. Left up is positive for us. Therefore, it is minus 30 plus 90. Yes, it is 60 kilonewton. Now from there I am going to the E left. Yes, no new load from B right to E left. Therefore it is 60 plus 0 is equal to 60 only. Then we are going to the E right. Yes, when I am going for the E right, I am taking the left part. What is the new entry there? 60 kilonewton is carrying the left part down. Therefore it is minus 60. Already 60 is there with me, plus this minus 60 will become equal to 60 minus 60 is equal to 0. So I have done SF calculations. I will try to complete the diagram. What is the procedure I told you? First you calculate the SF at important points. Then you put these ordinates at those locations to some scale. Then join those tips based on the variation of the SF. So first part we have completed. Now put the ordinates there. First SF at A left is 0. Draw the 0 line. Then from left to right I am going. SF is becoming plus 30. Then I am going for SF at D left, it is plus 30. Therefore at D left I am drawing a ordinate of plus 30. Remember, couple will not come in the calculation of the SF. From there I am going to D right. Just see what is SF at D right. Minus 30. It is to be drawn below the line. Minus 30. Then we are going for the SF at B left. SF at B left is minus 30. You draw there a line below 0 line of 30 kilonewton. Next, SF at B right. B right is plus 60. Therefore, you draw there a line. Ordinate of height is equal to plus 60. You need not to draw it to the scale. Approximately 30 and 60. If we say 60 should appear double as the 30. You need not to measure it. Here you are taking 3 centimeter, there 6 centimeter, not like that. That is not expected. Unnecessarily you are spending the time there. Okay. Now SF at E left is 60. Draw there an ordinate of 60. And right it is 0. Now I need to complete the diagram. For that, from A right I am going to the D left. 30, 30. Those 2 points are to be joined. Before joining I need to go for the loading diagram. If no load is there, SF line will be a parallel line. Means I need to join it by means of a straight line like this. Then from D right I am going to the B left. The values are minus 30 and minus 30. Those two are to be joined. How to join it? First you go for the loading diagram. Between D and B no load is there. Therefore SF will be constant. That is a line parallel to the zero line. Therefore you are drawing a line like this. Then you are going for B right to the E left. Again see, it is 60 and 60. But how it is to be joined? Whether it is to be joined by means of a curve, concave curve, convex curve, or a straight line, that is to be decided based on the loading in between it. Between B and E, between I am saying, there is no load. When there is no load, SF is constant. Means I need to join it by means of a parallel line. Now he is asking to mark the important or the silent points. Whether he is asking it or not, you need to do it. Important points in the SF diagram are the point where the SF changes its sign from positive to negative or negative to positive. Like if you are seeing the D, on the left of D it is positive, on the right of D it is negative. Therefore that point is important for me, particularly when the load is of higher order, like UDL, linear load, distributed load. That time these points play a very important role. Luckily that point is known to us here, that is at D, and again at the point B. These 2 points are called as the point of the zeros here, where the SF changes its sign. In SF, those are the important points. In BM, corresponding points are important. What is the reason? At those locations, BM will be either maximum or minimum around that particular point. That is why that point are important. One more is the point of contraflexure. Contra, changing, flexure, bending. Therefore, where the nature of bending changes, on one side of it tension is coming at the bottom, on the other side the tension is coming at the top, or one side it is positive, other side it is negative. That point are important for designing the structures, because wherever tension is coming, there we are supposed to put the steel. That you are studying in the higher classes, but anyhow you need to locate point of contraflexure, point of zero shear. Location of it is very easy. One way is, just if you see the diagram, yes, somewhere here the SF is 0. I don't know the location. Write the equation for the SF there and make it equal to 0. You will get the location of that point. The same thing you can do for the bending moment also. Yes. Now we are going for the BM calculation. So once again I am drawing that beam once again at the bottom. Why I am doing it is, in the examination it is not necessary to do it. Just tell you what you mean by the left, right, where is the location where I am calculating the SF per BM, I am drawing that diagram. In the examination, expected is that beam, only one you can write with the values of the reactions. Instead of writing only 90, you can write RA RB, and RA is equal to 30 kilonewton, RB is equal to 90 kilonewton. Like that you can write. Now going for BM calculation. First of all, where all we need to calculate the BM should be known to you. BM we are calculating at left and right of the couple. Wherever the couple is acting, there we need to calculate the BM at left and right of it. Next, at the point loads and at beginning and end of distributed load. Yes friends, major difference in SF calculations and BM calculations is at point loads you are calculating the SF at left and right. At a couple you are calculating the BM left and right. Couple you are not taking in SF calculation, and in BM calculation you are giving special importance for it, as you are calculating it left and right. And distributed load in both the cases is same, at beginning and end of the distributed load. And one more thing is, in whatever way you are adding, yes, I got the BM at B, you cannot add BM at B to BM at D. You have to calculate it independently. Like in SF we are doing, SF at left is known to me, then going for the right, what I am doing? Simply I am adding that particular load, because the distance won't come into picture in SF. But BM you cannot do it. Every time you need to do the new calculation there for BM. Whichever you feel comfortable, that you can adopt it. Yes, go for BM calculations. I am starting with BM at A. Yes, the right part is too complicated. I am going for the left part. No load on the left part. Therefore, the BM there is equal to 0. Next, BM I want at left of C. Left of C, when you are doing it, say where is the left of C? Here is. When you are saying couple is acting exactly at C, when you are saying the left of C, and if you are taking the left part, whether the couple come into picture or not. Yes, unmute the mic and tell me. You are taking the section at left of C, and calculation you are doing by considering the left part, whether that couple will be there in your calculation or not. Yes, the couple is exactly at C. You are cutting it at the left of C. Therefore, the right part, that couple will be there. But you are taking the calculation for the left part. Remember, in drawing the BMD, most danger force is the couple. It will always rotate you in the exam. as far as possible you be away from it. If unavoidable, we need to face it. What indirectly I want to say is, if you want at left of C, you take the left part for the calculation. If you want at right of C, you take the right part for the calculation, so that the couple will remain there only. But for practice, I tell you on both the sides. Now when I am going for left of C, only one force is there, that is 30. I need to take the moment at C, means just left to C. Therefore the distance will become 2 meter and 30 kilonewton. The force is acting in the upward direction. The beam will bend in upward direction. Therefore that bending moment is to be taken as positive. Therefore it is plus 30 into 2. Plus 30 into 2 is 60 kilonewton. If you are having the calculator, I will tell you how to calculate it by considering the right part, just for practice purpose. You can tell me the answer. Yes? Now you tell me if you are having the calculator. See the right part. Couple I will tell it afterwards. Afterwards in the sense at the end. First you go for 60. 60 into 2, the beam will bend in downward direction. Therefore it is minus 60 into 2. And that 60 into 5, beam will bend in downward direction. Therefore it is minus 60 into 5. And go for this 90. It is going in the upward direction. Therefore 90 into 4 is positive. Now go for the couple. Just whatever I am telling now, you listen to it carefully. You are considering the right part, means the left part is not there. Then you rotate the couple and hit the right part. How it bends the beam, you see it, and then you decide whether it is plus or minus. I can explain it in the classroom. Here it is a bit difficult for me. Are you getting what I want to say? Remove the left part and rotate the couple and see how it hits the beam. Whether it hits at the bottom or at the top. Yes, this couple, just see here, cursor is rotating like this. It has to hit the beam. When it hits the beam, it hits at the bottom. Therefore the beam will go up. Therefore the effect of the couple is positive. It is not that the clockwise or anti-clockwise. It is most dangerous force in bending moment diagram. Are you getting what I want to say? That couple, when you are rotating it, you are seeing the right part. What it is doing on the right part? It is hitting at the bottom. Therefore final answer, you just calculate it, plus 60 minus 60 into 2 minus 60 into 5 plus 90 into 4. Just tell me the number. I will repeat, plus 90 plus 120 plus 120 plus 90 into 4 minus 60 into 2 minus 60 into 5. Yes.
Plus 60, sir.
Plus 60 you got. On both the sides you got the same answer. Here, are you getting
Yes,
how
sir.
you are calculating the effect of the couple? If only one couple is there, no problem. You can consider one time right part, other side, left part, and they can escape out from the couple. But if two or more than two couples are there, somewhere we need to consider it. That is why you must be very careful about it. Are you getting how you are considering the effect of the couple if at all it is unavoidable? For example, you are considering the right part, left part is not there. Then you put the couple at the joint such that it has to hit the right part. ರೊಟೇಟ್ ಆಗಿ ಅದು ಬಂದು ತೆಳಗೆ ಹಿಟ್ ಮಾಡ್ತೈತೆ ರೈಟ್ ಪಾರ್ಟ್ಗೆ. ತೆಳಗೆ ಹಿಟ್ ಮಾಡ್ತಂದ್ರೆ ರೈಟ್ ಪಾರ್ಟ್ ಏನು ಹೋಗ್ತೈತಿ, ಮ್ಯಾಗ ಹೋಗ್ತೈತಿ. ಮ್ಯಾಗ ಹೋತಂದ್ರೆ ಬೆಂಡಿಂಗ್ ಮೂಮೆಂಟ್ ಪಾಸಿಟಿವ್. Right? Okay. Now we will do the calculation for the left of right of C. Just see, the right of C means what all coming? If I am taking the right part for the calculation, the couple will remain at C. I am taking the right part, couple will remain on the left part. Means that won't come into calculation if I am taking the right part for the calculation. Why I am taking the right part? I am getting confused with the couple. I want to avoid the couple. Therefore, see the calculation how it comes. 60 into 2 negative minus 60 into 5 plus 90 into 4. Whenever you want the bending moment about any point, all the distance are to be measured from that point only. Yes, 60 into 2 negative minus 60 into 5 plus 90 into 4. If you do it, you will get it as 60 into 5 minus 60 into 2 plus 90 into 4. You will get it as minus 60. This calculation you won't have any problem. Imagine that I am doing the bending moment at C at right, but I am taking the left part for the calculation. I am taking the left part for the calculation. Yes, that time whether the couple is to be included in my calculation or not. Couple is at C. I am cutting the beam at the right of C and I am taking the left part, as that point C will come on the left part, that couple will come on the left part. It is to be included in the calculation. So while you are writing here, you are not telling him which part you are taking. You are telling him only where you are taking. Got it? Therefore, on the left of C, on the left part, you are having the two forces. One force is that 30 kilonewton reactive force, and one more is couple of 120 kilonewton meter. Now again what I told, as per the couple is considered, you are taking the left part, means the right part is not there. You rotate the couple and hit the left part. See where it hits the beam or that particular part. Based on it, you need to decide whether it is plus or minus. Yes, can anybody tell me where, how it is hitting the left part? Try it. If it happens to be the offline, I could have told you in n number of ways, but online it is a bit difficult for me. See, you are removing the right part and rotating the couple and trying to hit the left part. That arrow, where it hits, how it hits. Otherwise, in the next class, I will prepare something different presentation to explain the effect of the couple. Here it hits in the top of AC. Therefore, beam bends in the downward direction. Therefore, the effect of the couple on the part AC is negative. Effect of the couple on the part CE is positive. That is what the dangerous part in the HFD and BMD. Couple will create the problem. Right? Therefore, on the left part, the calculation will be 30 into 2 minus 120. Therefore, answer will again become equal to minus 60. Yes. Now the bending moment at D. Friends, if you are told you are having any silly confusions, don't hesitate to ask it. I have the patience to answer for any of your questions. Okay, bending moment at D I want. As far as possible, I want to avoid the couple. That is why I will take the left part for the calculation. At D I want, but calculation I am doing by considering the left part. On the left part, D is 60 kilonewton is acting at D, means it is 0. Its distance. Therefore, only two forces are there. One is 90, one more is 60. Now 90 into 2. As I want bending moment from D, means distances are to be measured from D only. Therefore, it is 90 into 2 plus, and 60 is 60 into 3 is minus. Therefore, what is the net answer? 90 into 3 90 into 2 and minus 60 into 3. Is it correct? Yes. It is equal to 0. If you are checking it from other side, how you are checking it? Yes. From D, if you are taking, that time from the right side, left side, it will be 30 into 4. The beam is going up, positive, and 120 you pick it, keep it at D and hit the left part. Again it will become minus 120. 30 into 4 minus 120. Again it will become equal to 0. Like that, if at all you want to study this subject, best way is take any of the problem from any of the book and solve it by considering left part and right part. If you are getting the same answer, means you understood the concept, is the meaning of it. Almost everything we have covered in SFD and BMD, only we are practicing it. That is why you can select any problem from any of the book. If you are not getting the answer, Send it in WhatsApp. I'll give the answer to you people. Yes. Now, yes, BM at B. Again, I am considering the right part. See, in the calculation, you are not telling anything how you are doing the calculation. Only you are giving him the number. That is 60 into 1. Beam is bending in the downward direction. That is why it is negative. Minus 60 into 1. That is minus 60 at B. Lastly, at E, it is 0. So, I need to complete the diagram, BMD. Now, you go by one point. First, BM at A is 0. BM at C, left of C, is 60. Draw an ordinate of 60 there. First, yes, if you are coming from A to C, whether you are reaching plus 60 or minus 60, that you need to understand. From A you are coming for left of C. Left of C, how much it is? Plus 60. Therefore, you need to join from 0 to plus 60, not minus 60. Not minus 60, right? Therefore, these 2 points are to be joined. 0 and 60 is to be joined. How it is to be joined? You go for SF. SF indicates a constant there. Next to constant is the linear variation. Means you need to join it by means of a inclined straight line or straight line simply. Like this. Okay, you are taking the values at other coordinates. Then you are joining it. Then from there you are coming to right of C. From right of C, where you are going? You are going to D. Again, see the shape of the SF. Again, it is parallel line. If there it is parallel, here it will be inclined. Join it means of inclined line. Then from D you are going to B. What is the SF? BM at B? Minus 60. 0 and minus 60 is to be joined. How to join it? Again, it is parallel in SF line. Therefore, it is inclined in BM line. From there, I need to go to the end E. That is, BM at E is equal to 0. Join it by means of a inclined line, because here it is parallel line. So friends, how you are joining the SF lines or the BM lines? To some extent you are getting the concept there. No load, SF line will be a parallel line with 0 line. If constant UDL is there, SF line will be inclined one. If a triangular is there, SF line will be a parabola. Now coming for BM, whatever is there in SF, higher order will be in BM. It is parallel in SF, inclined in BM. If it is inclined in SF, parabola in BM. If parabola in SF, cubic curve in BM, like that. This completes the BM diagram, bending moment diagram. Above the line it is positive and below the line it is negative. Yes, this particular point where on one side of that point SF is positive, on the other side SF is negative. That point is called as the point of contraflexure. So how I can define the point of contraflexure? It is a point in the bending moment diagram where SF changes its sign from positive to negative or negative to positive. That is the definition. But importance when you are concerning it, when you are designing it, the structure in the higher semesters, you will come to know what is the importance of it. Yes, these are the important points. One more thing you need to understand here. At point of contraflexure, at point of zero shear, around that location, BM will be either maximum or minimum. Like for example, at D, point of zero shear is there. That will be the minimum bending moment there. That we cannot say well in advance. Either of the two it will be. Either it will be maximum or minimum. At D, it will be minimum, and at B, it is maximum around that point, not in a whole diagram. So anything to ask in SF or BM? That completes this SF and BM for this problem. Yes.
Sir, BM diagram ಇನ್ನೊಂದ್ಸಲ ಹೇಳಿ ಸರ್.
BM, we are starting with SF and BM are linked with each other. Where you are calculating, is there any confusion in connection with that one? ಎಲ್ಲೆಲ್ಲಿ ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡ್ಬೇಕು ಅದ್ರದ್ದೇನು ಪ್ರಾಬ್ಲಮ್ ಐತೇನ್ರಿ? ಇಲ್ಲ. ಇನ್ನು ಹೌ ಟು ಡ್ರಾ ಇಟ್, ಈಗ ಇಲ್ಲಿ ನಾವು ಸೀಕ್ವೆನ್ಸ್ ಕ್ಯಾಲ್ಕುಲೇಷನ್ ಸೀಕ್ವೆನ್ಸ್ ನೋಡ್ರಿ ಅಂದ್ರೆ ಎದಿಂದ ಸಿಗೆ ಬರ್ಬೇಕು ನಾವು ಫಸ್ಟ್, ಸಿದಿಂದ ಡಿಗೆ ಹೋಗ್ಬೇಕು, ಡಿದಿಂದ ಬಿಗೆ ಬರ್ಬೇಕು, ಎದಿಂದ ಸಿ ಲೆಫ್ಟಿಗೆ ಬರಬೇಕು, ಎದಿಂದ ಸಿ ಲೆಫ್ಟ್ಗೆ ಅಂದರೆ 0 to 60 ಐ ಹ್ಯಾವ್ ಟು ಮೂವ್. ಇನ್ನು ಅದನ್ನು ಹೆಂಗೆ ಜಾಯಿನ್ ಮಾಡಬೇಕು? ಇನ್ನು ಪ್ಯಾರಾಬೋಲಲ್ಲೇ ಜಾಯಿನ್ ಮಾಡಬೇಕು, ಏನು ಕರ್ವೋ ಅಥವಾ ಸ್ಟ್ರೇಟ್ ಲೈನು? ಇದು ಸಮಸ್ಯೆ ಬರ್ತದೆ ನಮ್ಗೆ. ಕರ್ವ್ ಇತ್ತು ಅಂದ್ರೆ ಕಾನ್ಕೇವ್ ಕರ್ವು, ಕಾನ್ವೆಕ್ಸ್ ಕರ್ವು, ಇವೆಲ್ಲ ಸಮಸ್ಯೆ ಬರ್ತಾವೆ. ಅದಕ್ಕೆ ಅದನ್ನು ಡಿಸೈಡ್ ಮಾಡೋಕ್ಕೆ ಎಸ್ ಎಫ್ ಇಲ್ಲ ಲೋಡ್ ಡಯಾಗ್ರಾಮ್ಗೆ ಹೋಗ್ಬೇಕು ನಾವು. ಎಸ್ ಎಫ್ ಡಯಾಗ್ರಾಮ್ಗೆ ಹೋದ್ರಿ ಅಂದ್ರೆ ಈ ಪರ್ಟಿಕ್ಯುಲರ್ ಪಾರ್ಟ್ ಏನು ಇಲ್ಲಿ 0 to 60 ಐತಲ್ಲ, ಈ ಪಾರ್ಟ್ ಯಾವುದಂದ್ರೆ ಎ ಟು ಸಿ. ಎ ಟು ಸಿದಾಗ ಎಸ್ ಎಫ್ ಡಯಾಗ್ರಾಮ್ ಹೆಂಗೈತಿ ನೋಡ್ಬೇಕು. ಎಸ್ ಎಫ್ ಡಯಾಗ್ರಾಮ್ ಸ್ಟ್ರೇಟ್ ಲೈನ್, ಪ್ಯಾರಲ್ ಸ್ಟ್ರೇಟ್ ಲೈನ್ ಇತ್ತಂದ್ರೆ ಬಿ ಎಮ್ದಾಗ ಅದು ಇನ್ಕ್ಲೈನ್ಡ್ ಆಕೈತಿ. ಎಸ್ ಎಫ್ದಾಗ ಇನ್ಕ್ಲೈನ್ಡ್ ಇತ್ತಂದ್ರೆ, ಇನ್ಕ್ಲೈನ್ ಲೈನ್ ಇತ್ತಂದ್ರೆ ಬಿ ಎಮ್ದಾಗ ಪ್ಯಾರಾಬೋಲಾ ಆಕೈತಿ. ಎಸ್ ಎಫ್ದಾಗ ಪ್ಯಾರಾಬೋಲಾ ಇತ್ತಂದ್ರೆ ಬಿ ಎಮ್ದಾಗ ಕ್ಯೂಬಿಕ್ ಕರ್ವ್ ಆಕೈತಿ. ಅಂದರೆ ಇಂಡೈರೆಕ್ಟ್ಲಿ ಎಸ್ ಎಫ್ದಾಗ ವೈ ಇಸ್ ಈಕ್ವಲ್ ಟು ಎ ಇತ್ತಂದ್ರೆ ಬಿ ಎಮ್ದಾಗ ಎ ಎಕ್ಸ್ ಆಕೈತಿ. ಎಸ್ ಎಫ್ದಾಗ ಎ ಎಕ್ಸ್ ಇತ್ತಂದ್ರೆ ಬಿ ಎಮ್ದಾಗ ಎ ಎಕ್ಸ್ ಸ್ಕ್ವೇರ್ ಆಕೈತಿ. ಇಂಟಿಗ್ರೇಷನ್ ಮಾಡಿದಂಗೆ ಇಂಡೈರೆಕ್ಟಾಗಿ. So, from left of C, we are going to right of C. That vertical drop is there. If you see, the amount of that drop is equal to the couple. From plus 60, we are going to minus 60. Now, from minus 60, that is C, I need to go to D. At D it is 0. Again these 2 points are to be joined. How to join it? That itself is our relationship between the load SF and BM. If SF is constant, BM will be inclined. Therefore their SF is constant, directly join it by means of a straight line. Like that we are drawing everywhere. Now what I told in connection with the point of zero shear is, here directly I got the point of zero shear. At some of the locations we won't be able to get it. Like if it is subjected to UDL, triangular load, that time when I need to join it by means of a curve. A curve ಎಲ್ಲಿ ಮ್ಯಾಕ್ಸ್ ಇರ್ತೈತಿ, ಎಲ್ಲಿ ಮಿನಿಮಮ್ ಇರ್ತೈತಿ, ಎಲ್ಲಿ ಕೂಡ್ತೈತಿ ಅದು ಸರಿಯಾಗಿ ಹೇಳಕ್ಕೆ ಬರೋಂಗಿಲ್ಲ ನಮಗೆ. ಆಗ ಈ ಪಾಯಿಂಟ್ ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡೋದು ಇಂಪಾರ್ಟೆಂಟ್ ಇರ್ತೈತಿ. ಇಲ್ಲೇನೈತಿ ಡೈರೆಕ್ಟ್ಲಿ ಆ ಪಾಯಿಂಟ್ ನಮ್ಗೆ ಗೊತ್ತದಾವ, ಬಟ್ ಆ ಪಾಯಿಂಟ್ದ ಇಂಪಾರ್ಟೆನ್ಸ್ ನಿಮ್ಗೆ ಇಂಡೈರೆಕ್ಟಾಗಿ ಹೇಳಿದೆ. ಎಲ್ಲಿ ಜೀರೋ ಶೇರ್ ಇರ್ತೈತಿ ಅದರ ಅಕ್ಕಪಕ್ಕದ ವ್ಯಾಲ್ಯೂ ಕಂಪೇರ್ ಮಾಡಿದ್ರೆ ಆ ಪಾಯಿಂಟ್ಗೆ ಎಸ್ ಎಫ್ 0 ಇರ್ತೈತಿ, ಮ್ಯಾಕ್ಸಿಮಮ್ ವರೆ ಇರ್ತೈತಿ ಇಲ್ಲಕ ಮಿನಿಮಮ್ ವರೆ ಇರ್ತೈತಿ. ಈಗ ಫಾರ್ ಎಕ್ಸಾಂಪಲ್ ಅರೌಂಡ್ ದ ಪಾಯಿಂಟ್ ಡಿ ಇಫ್ ಐ ಆಮ್ ಅಬ್ಸರ್ವಿಂಗ್, ಅದರ ಅಕ್ಕಪಕ್ಕ ಏನು ವ್ಯಾಲ್ಯೂಸ್ ಅದಾವಲ್ಲ ಅದಕ್ಕೆ ಕಂಪೇರ್ ಮಾಡಿದ್ರೆ ಹಿಯರ್ ಇಟ್ ಈಸ್ ಬಿಕಮಿಂಗ್ 0. ನೆಗೆಟಿವ್ ಇಫ್ ಯು ಆರ್ ಕನ್ಸಿಡರಿಂಗ್ ಅಗೇನ್ ವಿ ಕ್ಯಾನ್ ಸೇ ಇಟ್ ಈಸ್ ಮ್ಯಾಕ್ಸಿಮಮ್. ಅಂದ್ರೆ ಆ ಸರೌಂಡಿಂಗ್ದಾಗ ಅದ ಕಂಟ್ರೋಲಿಂಗ್ ವ್ಯಾಲ್ಯೂ ಇರ್ತೈತೆ ಅದು ಇಂಡೈರೆಕ್ಟಾಗಿ. Yes, like that if you are going for the point B, there also point of zeros here is there, and around that point if you see the values like 60 is the maximum there. ಅದರ ಅಕ್ಕಪಕ್ಕ ಏನು ವ್ಯಾಲ್ಯೂ ಇದಲ್ಲ ಅದು 60ಗಿಂತ ಕಮ್ಮಿ ಇದಾವೆ. ಇಲ್ಲಿ ಸ್ಟ್ರೇಟ್ ಲೈನ್ ಇರೋದ್ರಿಂದ ಅದೇನು ಕ್ಲಿಯರಾಗಿ ಗೊತ್ತಾಕೈತಿ. ಆದರೆ ಕರ್ವ್ ಅದು ಇತ್ತಂದ್ರೆ ಆ ಟೈಮ್ದಾಗ ಅವು ಇಂಪಾರ್ಟೆಂಟ್ ಆಕವು. Because at that point I need to calculate the SF and I need to check whether it is minimum or maximum. Okay? ಯಾವ್ದು ಕನ್ಫ್ಯೂಷನ್ ಉಳಿದಿತ್ತು ಅಂದ್ರೆ ಕೇಳಿ ನೋಡು. Yes? Any confusion?
No, sir.
Okay. We shall go for the next problem. Point of counterflexure you got. What do you mean by the point of counterflexure? Wherever the BM changes its sign, on one side of it, it is positive, on the other side of it, it is negative. Such point is called as the point of counterflexure. Nature of bending changes there. ಈ ಬೆಂಡಿಂಗ್ ಈಗ ನಿಮಗೆ ಹೇಳಿದ್ರೆ ಅಷ್ಟು ಇದಾಗಲ್ಲ. ಈಗ ಸ್ಯಾಗಿಂಗ್ ಬೆಂಡಿಂಗ್ ಮೂಮೆಂಟ್ ಇದೆ ಅಂತಂದ್ರೆ ಏನಾಗುತ್ತೆ ಅಂದ್ರೆ ಸ್ಟ್ರೆಚ್ ವಿಲ್ ಬಿ ಅಟ್ ದ ಬಾಟಮ್. ಬೀಮ್ ಕಟ್ ಆಗೋದಿದ್ರೆ ಬಾಟಮ್ನಿಂದ ಸ್ಟಾರ್ಟ್ ಆಕೈತಿ. ಹಾಗಿಂಗ್ ಬೆಂಡಿಂಗ್ ಮೂಮೆಂಟ್ ಅಂದ್ರೆ ಸ್ಟ್ರೆಚ್ ವಿಲ್ ಬಿ ಅಟ್ ದ ಟಾಪ್. ಬೀಮ್ ಕಟ್ ಆಗೋದಿತ್ತಂದ್ರೆ ಮ್ಯಾಗಿಂದ ಕಟ್ ಆಗಕ್ಕೆ ಸ್ಟಾರ್ಟ್ ಆಕೈತಿ. ಇದು ಸ್ಯಾಗಿಂಗ್ ಹಾಗಿಂಗ್ ನಮ್ಗೆ ಯಾಕೆ ಗೊತ್ತಿರ್ಬೇಕಂತಂದ್ರೆ ಅದು ಗೊತ್ತಾತಂದ್ರೆ ಮ್ಯಾಗಿಂದ ಕಟ್ ಆಕೈತಿ, ಹಂಗಾದ್ರೆ ಮ್ಯಾಗ್ ಸ್ಟೀಲ್ ಹಾಕುನು ಕಟ್ ಆಗೋದು ಸ್ಟಾಪ್ ಆಕೈತಿ. ತೆಳಗಿಂದ ಕಟ್ ಆಕೈತಿ, ಹಂಗಾದ್ರೆ ತೆಳಗೆ ಸ್ಟೀಲ್ ಹಾಕುನು ಕಟ್ ಆಗೋದು ಸ್ಟಾಪ್ ಆಕೈತಿ. ಅದಕ್ಕೆ ಸ್ಟೀಲ್ ಎಲ್ಲಿ ಹಾಕಬೇಕು, ಅದ್ರ ಬೆಂಡಿಂಗ್ ಇಫೆಕ್ಟ್ ಹೆಂಗೆ ನಾವು ಕಂಟ್ರೋಲ್ ಮಾಡ್ಬೋದು ಅದನ್ನು ಹೈಯರ್ ಸೆಮಿಸ್ಟರ್ ನೀವು ಕಲಿತೀರಿ. ಆದರೆ ಇಲ್ಲಿ ಏನಾಕೈತಿ, ಈ ಪಾಯಿಂಟ್ಗೆ ಒಂದು ಸೈಡ್ದಾಗ ಮ್ಯಾಗಿಂದ ಕಟ್ ಆಗ್ಲತ್ತಿ, ಇನ್ನೊಂದು ಸೈಡ್ದಾಗ ತೆಳಗಿಂದ ಕಟ್ ಆಗ್ಲತ್ತಿ. ಆಗ ನಾವು ಕಾಳಜಿ ತೊಗೋಬೇಕೈತಿ. ಬೀಮ್ ಮ್ಯಾಗ್ ಸ್ಟೀಲ್ ಮ್ಯಾಗ್ ಹಾಕಿದ್ರೆ ನಡೆಯಂಗಿಲ್ಲ, ಎರಡೂ ಕಡೆ ಹಾಕ್ಬೇಕೈತಿ, ತೆಳಗ ಮ್ಯಾಗ ಆ ಪರ್ಟಿಕ್ಯುಲರ್ ಪಾಯಿಂಟ್ ಸುತ್ತಮುತ್ತ. ಅದನ್ನು ನೀವು ಹೈಯರ್ ಸೆಮಿಸ್ಟರ್ದಾಗ ಕಲಿಬಿಡ್ತೀವಿ. ಅದಕ್ಕೆ ಎನಿ ಆಫ್ ದ್ಯಾಟ್ ಪಾಯಿಂಟ್ ಈಸ್ ಇಂಪಾರ್ಟೆಂಟ್ ಫಾರ್ ಮೀ. ದೇರ್ ದ ಬೆಂಡಿಂಗ್ ಮೂಮೆಂಟ್ ನೇಚರ್ ಈಸ್ ಚೇಂಜಿಂಗ್. ಓಕೆ. Draw SFD and BMD for cantilever beam of length L carrying UDL of intensity W per meter run. So here he has given you a cantilever beam. Length of the beam is L and it carries the load of intensity W per meter run. He is asking you to draw the SFD and BMD for it. ಭಾಳ ವಿಚಾರ ಮಾಡೋಕೆ ಹೋಗಿಲ್ಲ. SFD ಎಲ್ಲೆಲ್ಲಿ ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡಬೇಕು, BMD ಎಲ್ಲೆಲ್ಲಿ ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡಬೇಕು. SFD ಎಲ್ಲೆಲ್ಲಿ ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡತ್ತೆ ಹೇಳ್ತಾನವ, ಎಲ್ಲಿ ರಿಯಾಕ್ಷನ್ ಅಥವಾ ಪಾಯಿಂಟ್ ಲೋಡ್ ಬರ್ತೈತಿ ಅಲ್ಲಿ ಲೆಫ್ಟ್ ಆ್ಯಂಡ್ ರೈಟ್ ಬೇಕು. ಅದರ್ವೈಸ್ ಎಟ್ ದ ಬಿಗಿನಿಂಗ್ ಆ್ಯಂಡ್ ಎಂಡ್ ಆಫ್ ಡಿಸ್ಟ್ರಿಬ್ಯೂಟೆಡ್ ಲೋಡ್. ಅಂದ್ರೆ ಇದಕ್ಕೆ SF ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡೋದು ನೀವು ಎಲ್ಲೆಲ್ಲಿ ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡ್ತೀರಿ. ಈಗ ಎಟ್ B, ಎಟ್ ಲೆಫ್ಟ್ ಆಫ್ A ಆ್ಯಂಡ್ ರೈಟ್ ಆಫ್ A, ಈ 3 ಪಾಯಿಂಟ್ ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡೋದು. ಅದನ್ನು ಕಂಪ್ಲೀಟ್ ಹೆಂಗೆ ಮಾಡೋದು ಅಂದ್ರೆ ಅದನ್ನು ಲೋಡ್ ನೋಡಿ ಕಂಪ್ಲೀಟ್ ಮಾಡಬೇಕಾಗೈತಿ ಡಯಾಗ್ರಾಮ್. ಲೈಕ್ ದ್ಯಾಟ್ ಟು ಕ್ಯಾಲ್ಕುಲೇಟ್ ದ BM, ವೇರ್ ಆಲ್ ಐ ನೀಡ್ ಟು ಕ್ಯಾಲ್ಕುಲೇಟ್ ದ BM. ಎಟ್ ಲೆಫ್ಟ್ ಆ್ಯಂಡ್ ರೈಟ್ ಆಫ್ ಕಪಲ್, ಇಲ್ಲಿ ಕಪಲ್ ಎಲ್ಲಿ ಬರ್ತೈತೆ ರೀ, ಫಿಕ್ಸ್ಡ್ ಆ್ಯಂಡ್ ಎ ಐತೆ ಅಂದ್ರೆ ಎಗೆ ರೆಸಿಸ್ಟಿಂಗ್ ಮೂಮೆಂಟ್ ಬರ್ತೈತಿ. ಅದಕ್ಕೆ ಏದು ಲೆಫ್ಟ್ ಏದು ರೈಟ್ ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡಬೇಕು. ಆಮೇಲೆ ಎಟ್ ಎ ಆ್ಯಂಡ್ ಬಿ ಡಿಸ್ಟ್ರಿಬ್ಯೂಟೆಡ್ ಲೋಡ್ ಇರೋದ್ರಿಂದ like that we need to understand first where all I need to calculate the SF, where all I need to calculate the BM, how to complete it. Yes, to start with, ಈಗ ಕ್ಯಾಂಟಿಲಿವರ್ ಬೀಮ್ ಬತ್ತಂದ್ರೆ ಯೂಶ್ವಲಿ ನಾವೇನು ಮಾಡ್ತೀವಿ ಅಂದ್ರೆ ರಿಯಾಕ್ಷನ್ ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡೋಂಗಿಲ್ಲ, ಡೈರೆಕ್ಟ್ಲಿ ಪ್ರೀ ಎಂಡ್ದಿಂದ ಸ್ಟಾರ್ಟ್ ಮಾಡ್ತೀವಿ, ಫಿಕ್ಸ್ಡ್ ಎಂಡ್ ಹತ್ತಿಗೆ ಹೋಗೋಣ ಜಂಪ್ ಮಾಡ್ತೀವಿ. ಅಂದ್ರೆ ಅದು ಕಪಲ್ ಇರಲಿ ಅಥವಾ ಮತ್ತೇನಿರಲಿ ಅಲ್ಲೇ ಉಳಿದೈತೆ. ಅದು ಜಂಪ್ ಮಾಡ್ತೀವಿ ಇನ್ ದ ಸೆನ್ಸ್ ಈ ಕಡೆಯಿಂದ ರೈಟ್ ಬರ್ತಿದ್ದೀವಿ ಅಂದ್ರೆ ಅಲ್ಲಿ ಹೋಗೋಣ ಒಮ್ಮೆ ಲೆಫ್ಟಿಗೆ ಜಂಪ್ ಹೊಡಿದ ಲೆಫ್ಟ್ ಸೈಡ್ ಕನ್ಸಿಡರ್ ಮಾಡೋದು. ಸೊ ದ್ಯಾಟ್ ಕ್ಯಾಲ್ಕುಲೇಷನ್ ಆಫ್ ರಿಯಾಕ್ಷನ್ಸು, ಆ ರಿಯಾಕ್ಷನ್ ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡಿದ್ರಾಗ ಮಿಸ್ಟೇಕ್ ಬತ್ತು, ಅದು ದ್ಯಾಟ್ ಇಸ್ ಕ್ಯಾರಿಡ್. ಟು ಅವಾಯ್ಡ್ ದ್ಯಾಟ್ ಒನ್ ವಿ ಆರ್ ನಾಟ್ ಲುಕಿಂಗ್ ಎಟ್ ದ ಫಿಕ್ಸ್ಡ್ ಎಂಡ್. ಓಕೆ, ಫಸ್ಟ್ SF calculations. Here reactions we are not calculating it. SF at left of A. ಲೆಫ್ಟ್ ಆಫ್ ಎ ಅಂದಮೇಲೆ ಇಲ್ಲಿ ಇದೇಗಿನ ಪ್ರೊಸೀಜರ್ ಅಡಾಪ್ಟ್ ಮಾಡಿ ನಡೆಯಂಗಿಲ್ಲ. ಇಲ್ಲಿ ತನಕ ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡೀನಿ, ಇಲ್ಲಿ ಇದನ್ನು ಕೂಡ್ಸುನು ಕಳೀನು ಅಂತ ಏನು ಮಾಡ್ತೀವಿಲ್ಲ, ಇಲ್ಲಿ ಕ್ಯಾಂಟಿಲಿವರ್ದಾಗ ಒಂದು ರಿಯಾಕ್ಷನ್ ನಮ್ಗೆ ಗೊತ್ತಿರಂಗಿಲ್ಲ, ನಾನು ಅದನ್ನು ಮಾಡೋಂಗಿಲ್ಲ. ನಾವಿಲ್ಲಿ ಒಂದು ಪೂರ್ತಿ ಸೈಡ್ದಾಗ ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡ್ತೀವಿ, ಆ ಕಡೆದರೆ ಈ ಕಡೆದರೆ ಹಿಂಗೆ. ಈಗ SF ಎಟ್ ಲೆಫ್ಟ್ ಆಫ್ ಎ, ರೈಟ್ ಆಫ್ ಎ, SF ಎಟ್ ರೈಟ್ ಆಫ್ ಎ. ಈಗ ಲೆಫ್ಟ್ ಪಾರ್ಟ್ನ ರೈಟ್ ಪಾರ್ಟ್ನ ಕ್ಯಾಲ್ಕುಲೇಷನ್ ತೊಗೊಂಡು ಅಂದ್ರೆ ಅಲ್ಲಿ ರಿಯಾಕ್ಷನ್ಸು ಬರ್ತಾವೆ, ಇದು ಲೋಡು ಬರ್ತೈತಿ. ಬೆಸ್ಟ್ ವೇ ಏನು ಮಾಡ್ತೀನಿ ನಾನು, ಐ ವಿಲ್ ಟೇಕ್ ದ ಲೆಫ್ಟ್ ಪಾರ್ಟ್ ಫಾರ್ ದ ಕ್ಯಾಲ್ಕುಲೇಷನ್. ನೋ ಲೋಡ್ ಆನ್ ದ ಲೆಫ್ಟ್ ಪಾರ್ಟ್, ದಟ್ ಈಸ್ ವೈ SF ಎಟ್ ಎ ಲೆಫ್ಟ್ ಈಸ್ ಈಕ್ವಲ್ ಟು 0. ಈಗ ಕೆಂಪು ರೆಡ್ ಲೈನ್ ಬಿಡ್ತಾನಲ್ರಿ, ಅದ್ರದ್ದು ಲೆಫ್ಟ್ ಸೈಡ್ ಏನೂ ಲೋಡ್ ಇಲ್ಲ ನಂದು. SF ಅಂದ್ರೆ ಏನು, ಟೋಟಲ್ ಆಫ್ ಆಲ್ ದ ಲೋಡ್ಸ್ ಐದರ್ ಆನ್ ದ ಲೆಫ್ಟ್ ಸೈಡ್ ಆರ್ ಆನ್ ದ ರೈಟ್ ಸೈಡ್. ಎಪ್ಪು ರೈಟ್ ಸೈಡ್ ಐತಿ ಮತ್ತು ಅದನ್ನು ಕನ್ಸಿಡರ್ ಮಾಡ್ಲಿಕ್ಕೆ ತಪ್ಪಾಕತಿ ಅಂತ ವಿಚಾರ ಮಾಡೋಕೆ ಹೋಗ್ಬೇಡ್ರಿ. ನಿಮ್ಗೆ ಯಾವ್ದು ಈಜಿ ಅನಿಸ್ತೋ ಪ್ರಾಕ್ಟೀಸ್ ಮಾಡೋತಾನೆ ಯಾವ್ದು ಬೇಕಾದ್ರು ಮಾಡಿರಿ. ಒನ್ ಯು ಗಾಟ್ ದ ಕಂಟ್ರೋಲ್ ಓವರ್ ದ ಸಬ್ಜೆಕ್ಟ್, ವಿಚ್ ಎವರ್ ಯು ಫೀಲ್ ಕನ್ವೀನಿಯಂಟ್, ಈಸಿ, ದ್ಯಾಟ್ ಯು ಅಡಾಪ್ಟ್ ಇಟ್. SF at A left is equal to 0. Now SF at A right, why I am calculating at left and right? Because there is a point reaction. Therefore next I want SF at A right. What is there on the right? Now I am not doing left part for the calculation, I am taking the right part for the calculation. Are you getting the reason for it? ಲೆಫ್ಟ್ ಪಾರ್ಟ್ ಹೋದ್ರೆ ಅಂದ್ರೆ ನಿಮ್ಗೆ ಅಲ್ಲಿ ರಿಯಾಕ್ಷನ್ಸ್ ಗೊತ್ತಿಲ್ಲ, ಅದಕ್ಕೆ ಬೆಟರ್ ಐ ಆಮ್ ಟೇಕಿಂಗ್ ದ ರೈಟ್ ಪಾರ್ಟ್. ರೈಟ್ ಪಾರ್ಟ್ದಾಗ ಏನು ಲೋಡ್ದಾವ ನೋಡ್ರಿ, ಟೋಟಲ ಒಂದ ಲೋಡತಿ UDL. ಇಟ್ ಈಸ್ W per meter run. And how much length it is acting? L length it is acting. Now you tell me whether it is plus or minus. Yes.
Plus, sir.
Plus, yes. Because you are taking the right part for the calculation and the right is going down. Means the left is up. My SF is positive. And its value is equal to W into L. Therefore, SF at A right is W into L. Now I need to calculate the SF directly at B. What I told, at left and right a point load, start and end of UDL. Already we are having at start of UDL, end of UDL is the B. Now I want the SF at B. ಈಗ ಯಾವ ಪಾರ್ಟ್ ಕನ್ಸಿಡರ್ ಮಾಡ್ತೀರಿ? Yes, we are taking the calculation by considering the left part. ಅಲ್ಲೇನು ಸಿಂಪ್ಲಿ ಸಪೋರ್ಟೆಡ್ ಬೀಮ್ ಇದ್ದಾಗ ಕ್ಯುಮ್ಯುಲೇಟಿವ್ ಹೊತ್ತು ಹೋಗಿದ್ವಲ್ರಿ, ಅದನ್ನ ಇಲ್ಲಿ ಮಾಡಂಗಿಲ್ಲ. ಮಾಡ್ಬೇಕಂದ್ರೆ ಪೈಲ ಅವು ಎಲ್ಲ ರಿಯಾಕ್ಷನ್ಸ್ ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡಬೇಕು. ಅದಕ್ಕೆ ಇಲ್ಲಿ ಟೋಟಲ್ ಲೆಫ್ಟ್ ಆರ್ ರೈಟ್ ವಿ ಆರ್ ಗೋಯಿಂಗ್ ಹಿಯರ್. ದೇರ್ಫೋರ್ SF at B equal to 0. I am seeing towards the left side. Now I got SF at all the points. I need to complete the diagram. Yes, if I am starting from A, first the SF is 0. Write the 0 line. First SF at A is 0, then it goes to WL and is positive. You draw an ordinate there, WL. It is actually at SF A right. From A right you are going to B. What is the SF there? 0. These two tips are to be joined. But how to join it? Go for the load. What type of load is there? At any section you consider, what you are writing there? Load is W per meter run. Means load is same everywhere. Load is constant. Load constant ಇದ್ರೆ SF inclined ಆಕೈತಿ. SF ಕಾನ್ಸ್ಟೆಂಟ್ ಇತ್ತಂದ್ರೆ BM inclined ಆಕೈತಿ. ಲೋಡ್ ಇನ್ಕ್ಲೈನ್ಡ್ ಇತ್ತಂದ್ರೆ SM ಪ್ಯಾರಾಬೋಲಾ ಆಕೈತಿ, SF. BM ಕ್ಯೂಬಿಕ್ ಕರ್ವ್ ಆಕೈತಿ. ಆ ಥರ ಕ್ಯಾಲ್ಕುಲೇಷನ್ ಮಾಡ್ಬೇಕು ನಾವು. SF at B, these 2 points are to be joined. These are to be joined as the load is constant. Here I need to join it by means of a straight line. You need not to write there as it is a straight line. It is understood. ಗಣಪತಿ ಹೊಡೋದ್ರ ಬೇಟ ಗಣಪತಿ ಬರೋ ಅವಶ್ಯಕತೆ ಇಲ್ಲ. ಯಾಕಂದರೆ ಈಸ್ ಯೂನಿಕ್. ಬೇರೆ ದೇವರಿದ್ದು ಅಂದರೆ ಅಷ್ಟ ಬರೀಬೇಕು ಆ ದೇವರ ಹೆಸರು. Yes, now I need to go for the BM calculations. Tell me where all you are calculating the BMs. What he told in connection with the BM? Left and right of couple at start and end of UDL. Therefore, here you are calculating the BM at A left, A right. Then at A and B. Just see how we can do it. First, BM calculations. BM at A left. Yes, again, whichever you feel convenient, that you can adopt. I am taking left side for the calculation and I want it at left. Therefore, if I see the left side of that line, nothing is there. Therefore, BM there is equal to 0. BM at A left is equal to 0. Now, next I need to go for BM at A right. Again, I want at BM at A right, but at A couple is there. Right side I am taking and right part I am taking. Couple is remaining on the left part only. Therefore, I am seeing the right side of it. Yes, only one load is there. That is UDL. I need to measure magnitude of the load and distance from A. Magnitude of load is W into L. From A, where it is acting? UDL means it will act at the center. That is L by 2 from A or L by 2 from B. Therefore, the load is W into L and distance is L by 2. Now, whether the beam bends in downward or upward. Beam bends in downward direction. Therefore, the BM is to be taken as the negative. Minus WL into L by 2 is equal to WL square by 2. Now one more thing. To arrive at, okay, I know SF BM at A left, BM at A right, I want BM at B. Now I am taking the right part for the calculation. What is there on the right part? Nothing is there. Therefore BM at right of B, BM at B is equal to 0. Now comes the problem. I got BM at B, I got BM at A right. These two ordinates are to be joined. How it is to be joined? First you go for the SF diagram. SF ದಾಗ ಇನ್ಕ್ಲೈನ್ಡ್ ಇತ್ತಂದ್ರೆ ಬಿ ಎಮ್ದಾಗ ಏನಾಕತ್ರಿ? Yes, if it is inclined in SF diagram, BM ದಾಗ higher, inclined ಮುಂದಿನ ಅಂದ್ರೆ parabola. Therefore, those 2 points are to be joined by means of a parabola.
Parabola.
ಈಗ ಪ್ಯಾರಾಬೋಲಾ ನಾವು ಹೊಡೆಯುವಾಗ ಇನ್ನೊಂದು ಪ್ರಾಬ್ಲಮ್ ಏನು ಬರ್ತದೆ ನಮಗೆ? ಅದ್ರದ್ದು ಹೈಯೆಸ್ಟ್ ಪವರ್ ಎಲ್ಲಿದೆ, ಅಲ್ಲಿ ಹೈಯೆಸ್ಟ್ ಆರ್ಡರ್ ಎಲ್ಲಿದೆ ಅಂದ್ರೆ ಎಲ್ಲಿ ಟಿಪ್ ಇದೆ ಆ ಪ್ಯಾರಾಬೋಲಾದು ಅಂದ್ರೆ ಈ ಲೈನ್ ಏನು ಕಾನ್ಕೇವ್ ಕರ್ವ್ ಬರ್ತೈತೋ, ಕಾನ್ವೆಕ್ಸ್ ಕರ್ವ್ ಬರ್ತೈತೋ ಅಥವಾ ಸಾದಾ ಕರ್ವ್ ಬರ್ತೈತೋ ಅದನ್ನು ಡಿಸೈಡ್ ಮಾಡ್ಬೇಕಾದ್ರೆ ನಾವು ಮತ್ತೆ ಎಸ್ ಎಫ್ಗೆ ಹೋಗ್ಬೇಕು. ಎಲ್ಲರೇ ಎಸ್ ಎಫ್ ತನ್ನ ಸೈನ್ ಚೇಂಜ್ ಮಾಡ್ತೈತೆ ಅಂತ ನೋಡ್ಬೇಕು. ಎಲ್ಲೂ ಚೇಂಜ್ ಮಾಡೋಂಗಿಲ್ಲ. ಎಟ್ ಎ ಆ್ಯಂಡ್ ಬಿ ಬಿಟ್ರೆ ಅಂದರೆ ಎ ಆ್ಯಂಡ್ ಬಿದಾಗೇನು ವ್ಯಾಲ್ಯೂ ಇದಾವಲ್ಲ ಅವ ಮ್ಯಾಕ್ಸಿಮಮ್ ಮಿನಿಮಮ್, ಅದಕ್ಕಿಂತ ಮ್ಯಾಗಿಂದಾಗಲಿ ತೆಳಗಿಂದಾಗಲಿ ಇಲ್ಲ ಅಂದ್ರೆ ಅವ ಮ್ಯಾಕ್ಸಿಮಮ್ ಮಿನಿಮಮ್ ಹಿಡ್ಕೊಂಡು ನಾವು ಲೈನ್ ಹೊಡಿಬೇಕು. ಏಕಿಂತ ಹೆಚ್ಚಿಗೆ ಹೋಗಬಾರ್ದು ನಾವು. ಎಸ್ ಎಫ್ ಏನಾರು ಲೈನ್ ಕ್ರಾಸ್ ಮಾಡಿತ್ತಂದ್ರೆ ಆಗ ಪಾಯಿಂಟ್ ಹುಡುಕಾಡಿ ಅಲ್ಲಿ ಬಿ ಎಮ್ ಮ್ಯಾಕ್ಸಿಮಮ್ ಇರುತ್ತೆ, ಗೊತ್ತಾಗತ್ತೆ ನಿಮ್ಗೆ ಆಮೇಲೆ. ಅದಕ್ಕೆ ಡೈರೆಕ್ಟ್ ನಾವು ಒಂದು ಕರ್ವ್ ಹೊಡೆದ್ಬಿಟ್ರೆ ಮುಗಿದೋತಿಲ್ಲ. WL²/2 ನೆಗೆಟಿವ್ ಇಷ್ಟು ಕರ್ವ್ ಹೊಡೆದ್ರೆ ಮುಗಿದೋತು. ಹೊರಗೆ ಯಾಕೆ ಬರೋಂಗಿಲ್ಲ ಕರ್ವ್ ಅಂತಂದ್ರೆ ನಿಮಗೆ ಎಸ್ ಎಫ್ದಾಗ ಜೀರೋ ಲೈನ್ ಎಲ್ಲೂ ಇಲ್ಲ, ಅದು ಪಾಯಿಂಟ್ ಆಫ್ ಜೀರೋ ಸಿಯರ್ ಇಲ್ಲಿ ವೇರ್ ಎಸ್ ಎಫ್ ಇಸ್ ಚೇಂಜಿಂಗ್ ಇಟ್ ಸೈನ್ ಫ್ರಮ್ ಪಾಸಿಟಿವ್ ಟು ನೆಗೆಟಿವ್, ನೆಗೆಟಿವ್ ಟು ಪಾಸಿಟಿವ್. ಅದಿಲ್ಲ ಅನ್ನೋ ಇದ ಫೈನಲ್ ಆಕತಿ ಆಯ್ತಾ. ಹಿಯರ್ ವಿ ಆರ್ ಕನ್ಕ್ಲೂಡಿಂಗ್ ವಿತ್ ದ ಟುಡೇ ಸೆಷನು. ಈಗೇನು ಕೇಳೋದಿದ್ರೆ ಕೇಳ್ರಿ.